The third FRQ in this year's student work is an FRQ that I call geometric graph. It's the first one that is non-calculator. We have to feel relieved when we see an FRQ with a graph like this, composed of lines and semicircles or quarters of circles, because we can be sure that we at least know one or two of the questions that are going to be asked, and that's always a good sign. Now, it's interesting this year because for the first time L'Hôpital's rule is part of the AP Calculus AB exam, and they actually placed a question in this FRQ where we need to use L'Hôpital's rule. So it's particularly interesting to see how they will use it. So before I start reading, I want to mention that the graph is up here above the question, and you can scribble everything you want on that graph, but you should never imagine that this will count towards your answer. If you write the answer to question A here or to question B here, it is not going to count. You have to put your answer in the space provided for each question. Likewise, you have to put the answer to question B in the box for question B and the answer to question C in the box for question C. They won't give you any point if they find an answer that's not in the correct place. That said, for the sake of this keynote and screencast, I myself moved the picture of this graph below because it takes less room, and also because each student wrote stuff there that are interesting. Even if they don't give points toward the score of the exam, it's still interesting to see how the students worked the problems with the graph. So a continuous function g is defined on the closed interval -8, 6. The graph of g shown above consists of 3 line segments and a quarter of a circle centered at the point 0, 2. Line segments 1, 2, 3, and quarter of a circle, it's centered right here. There's no surprise. I think they just need to be very clear about it, but what you see is what you have. There's no trick. Let f be the function given by f of x equals the integral from -8 to x of g of t dt. So let's jump right into it. This is student A, and as I said, I screenshotted their graph every time so that we can see sometimes what they did. Question A is find all values of x in the interval -8, 6 at which f has a critical point. Classify each critical point as the location of a local minimum, local maximum, or neither. Justify your answers. Firstly, let's review quickly what a critical point is. A critical point of f is a value x at which f prime of x equals 0 or f prime of x is undefined. There's only two cases, f prime of x equals 0, f prime of x is undefined. You know, we often also look for endpoints. When we're looking for an absolute maximum, we include the endpoints, but the endpoints are not critical points. They are something else that we add in certain types of exercises, and it's going to happen this year as well in another FRQ, I think. So critical points only f prime of x equals 0 and f prime of x undefined. In this case, f prime of x is the derivative of this expression, and because of the fundamental theorem of calculus, it is actually equal to g of x. We confirm that we have a constant as the lower bound and we have x as the upper bound, so it's easy. F prime of x equals g of x. So this transforms the problem into finding where g of x equals 0 and where g of x is undefined. G of x equals 0 here at x equals -6 and here at x equals 2. So that's great. We already found two critical points, g of x equals -6 and x equals 2. What about g of x undefined? Well, g of x is defined absolutely everywhere. I can choose this point here, -4, and g of -4 equals 2. So g of x is perfectly defined. There are no places in the interval where g of x is undefined. Don't get confused. We all see that there's a sharp turn here and a sharp turn there and a sharp turn there. That's not g of x being undefined. G prime of x would be undefined for sure, but this is not related to the question of g of x. So there are only two critical points, x equals -6 and x equals 2. Now we still need to determine whether they are local minimum, local maximums, or neither. And this is done by thinking of the sign of the derivative and how it changes. So g, which is f prime, changes from negative to positive at x equals -6, and therefore this is a minimum. F has a minimum. At x equals 2, the derivative changes from positive to negative, and so the original function f has a maximum. This is what the student wrote here. That student earned the 3 points that you could earn in this exercise, first by mentioning that f prime of x equals g of x, then by stating the two critical points, and finally by determining what type of critical points they are and why. Student B did roughly the same, so I'm not going to go on that forever. They first wrote that g of x equals f prime of x, which is great, and that allowed them to identify x equals -6 and x equals 2, and they found that it's a minimum and a maximum. But unfortunately for this student, their explanation, their justification is not okay for AP Calculus AB. We said many times that in AP Calculus, if you want one of your justifications to be acceptable, first of all, it needs to be written, which is the case here. You can't just make a graph or a sketch and hope that that's going to count. But secondly, it needs to use some calculus concepts. It needs to typically mention the derivative and say the derivative is positive. If you just say that the graph is increasing and then decreasing, sure, if a graph is increasing and then decreasing, we met a maximum. But that's not okay for AP Calculus because any pre-calculus student would understand that. In fact, any Algebra 2 student would also understand that. So it doesn't demonstrate that you get calculus concepts. So this is what happens in this explanation here. The student talks about the graph increasing or decreasing and then increasing. This will not earn you points. So, first point, g of x equals f prime of x. I want to say something that's really, or emphasize something that's really important. Here the student wrote this here, it's great, but you have to remember this is at the top of the page, it's not in the box for question A, and there's a huge chance that you won't earn any point, even if this is correct, and it is one of the points, you have to write it down in the appropriate box. Second point earned for the correct values, but as we said, the third point is not earned because the explanation doesn't use calculus concepts. Student C is a little counterexample to what I just said. That student only wrote f prime here next to g at the top of the page, and I guess the graders were extremely lenient that year, but they gave that student a point. So 1 point for this, 1 point for finding x equals 2 and -6, and 1 point for a correct explanation. Let's read it because it's easier to read than the other two students. There is a local min at x equals -6 because f prime changes from negative to positive. And there's a local max at x equals 2 because f prime changes signs from positive to negative. Great, perfect. Every time f prime is mentioned, it also means g. So lucky here, really don't do that, write f prime of x equals g of x somewhere in the box for answer A. Question B, find f of 0. That's such a good question. We are completely sure we'll get the points that can be earned. So f of 0 is the integral from -8 to 0 of g of t dt, which is the signed area under the graph or between the graph and the x-axis. So let's look at student A. From -8 to x equals 0. This is a triangle, and by using base times height over 2, the signed area is -2. It happens that we have exactly the same triangle here. The signed area is 2, and these two will cancel out. And now we have a rectangle with area 8 and a quarter of a circle. This circle has a radius 4, so the area of that quarter circle is pi r squared over 4, which is 4 pi. Conclusion, f of 0, which is the integral from -8 to 0 of g of t dt, is this -2 plus 2 plus 8 plus 4 pi, and that's equal to 8 plus 4 pi. Let's emphasize again that if we talked about the integral from -8 to -4, the answer would be 0 because these two triangles cancel out. It's going to be important later on in a further question. Great, 1 point, and that student earned it. Student B, same kind of thing. They wrote the arithmetics here and they get the right answer, so they also earned 1 point. And finally, student C got a little bit confused breaking down this area here in kind of strained triangles. It's not wrong, but it certainly doesn't help if you don't see an easier way to split this region. And in the end, there's a little mistake. I don't think it's worth really going into the why. It's just a stupid mistake that we can all avoid. Question C. Find the limit as x approaches -4 of f of x over x squared plus 4x. And this is what I just mentioned earlier. As x approaches -4, the first thing you want to do when you look for a limit is to try to simply plug in x equals -4, direct substitution, and see what happens. But what happens is that f of -4 is the integral from -8 to -4 of g of t dt, which is the signed area from here to here. And that is equal to 0. At the denominator, if we plug in x equals -4, we also get 0. We get 16 minus 16 equals 0. When we get a case of a limit being 0 over 0, what do? We use L'Hopital's rule, and that means taking the derivative of the numerator, taking the derivative of the denominator, and again trying direct substitution at that point. This is precisely what the student did. First of all, he or she found that originally if I plug in, I get 0 over 0, so great summary here, the limit is 0 over 0. And then differentiating, so the derivative of f of x is g of x. The derivative of x squared plus 4x is 2x plus 4. They found that this is equal to 2 over -4. So 2 over -4 equals -1 over 2. So regarding points, how did it work? There was 1 point to be earned by showing and using L'Hopital's rule. What I mean by showing is that you have to show that you are in a situation that is 0 over 0. So here, this is really great. It's 0 over 0. There's even the explanations of how they got this result. And then they did use L'Hopital's rule, so f prime of x divided by the derivative of x squared plus 4x, and that was 1 point. The second point was earned if they could follow up and try to plug in the value x equals -4 again, and the student did that, so they earned a point for the correct answer. Student B it's worth looking a little bit at what happened. That student states 0 over 0, however, with no explanation. So I'm not very sure what would have happened to that first point. But anyway, the student got quite confused. Instead of doing f prime of x, and instead of finding the derivative of x squared plus 4x, that student actually took the quotient rule and went somewhere that really we're not supposed to go. So if that student had just written 0 over 0 without explaining how they found that, I don't know if they would have earned the point, but if you have no clue what to do, I guess it's a good bluff. So 0, and then, well, there was no hope from there. Student C also kind of tries to use L'Hopital's rule, but no justification, and definitely doesn't even say 0 over 0, doesn't show why it's 0 over 0, so here they didn't earn the point. However, they did use L'Hopital's rule correctly and reach the right answer. So here there's 1 point for the answer, 0 point for the lack of explanation. Last question for this FRQ. Let h be the function defined by h of x equals g of x over x squared plus 1. Find h prime of 1. Now this is a place where you want to use the quotient rule. H prime of 1 is going to be, it's u over v, so it's u prime v minus uv prime over v squared. The student does exactly that, g prime, so u prime v minus u v prime over v squared. And from there, all you need to do is to plug in x equals 1, and when you want to find g prime of 1, you check what is the slope at x equals 1, and it's negative 3. How do we find negative 3? We just do rise over run, which is negative 9 over 3. So this is how this g prime of 1 becomes negative 3. What about g of 1? G of 1 is simply the value of g at x equals 1. So it's here, it's 3. And that's how g of 1 becomes 3. Technically, you could stop here and get full credit. Most students still go all the way and write the answer as negative 3. So great job. Here 2 points earned for writing the correct quotient rule, and then 1 extra point for reaching the correct answer. Student B got 2 points for the quotient rule and also 1 point for reaching the correct answer, so I won't give too many details. And finally, student C doesn't get the right answer. We can quickly look at what happened. There's actually 2 things that went wrong. Firstly, u prime v, this is v. There's no parenthesis here, and I bet the student knew exactly that there should be a parenthesis, but they didn't write it. But it's obvious, so let's not put the parenthesis, it doesn't matter. Unfortunately, later on, they forgot that there was supposed to be a parenthesis. It becomes more and more unclear for sure, so yeah, be careful with that. And also, actually I'm not 100% sure this is what happened. I think instead of minus 6, which is negative 12, somehow it became negative 6 plus 6, which is 0. Doesn't really matter, but I want to say don't do that. It's bad math and it exposes you to mistakes later on in exercises. There's another mistake here in this problem. The denominator should be, so it's u prime v minus uv prime over v squared, and there's no squared here. So this should be 2 squared, and it's only 2. Anyway, 0 points here. It's a bit of a pity because that question D wasn't the hardest question ever. So there was a chance to get more than 0 out of 3. Anyway, that's it for this FRQ on geometric graph. Thank you very much for listening, and I really hope it helped you.